Energy is transferred to water in a flask at a rate P. So P is the power. The water reaches boiling point and then P is increased. So P is the rate at which the energy is transferred. What are the changes to the temperature of the water and to the rate of vaporization after the change is made? So let's say we have a flask in which we have kept some water and we are providing heat energy from below at a rate of P. So P is the power. Now it's mentioned that the water reaches boiling point, which means the water is at 100 degrees Celsius and hence it is boiling. Now remember the basic point. Whenever boiling is taking place, it is the liquid water which is converting into gas, in this case steam. And whenever this transition happens, temperature does not change. So temperature stays constant. So let me repeat. Whenever the phase changes, the temperature stays constant. So we are going from water to gas. There is a change of phase and hence temperature is unchanged. So which means A and B options can be discarded. Temperature is unchanged. Now to find the rate of vaporization, it is m by T. Rate of vaporization stands for the rate at which mass of the water is being vaporized into steam. So that is m by T. So how do we find that out? So we recall the formula whenever phase changes, we use the formula of Q is equal to ml. Now, if we divide both sides of this equation with time, we'll get this. And Q by T is energy by T. By definition, that is power P. And on the right hand side, we have a m by T. So like we discussed earlier, m by T stands for the rate of vaporization, which we are supposed to find. Hence, our equation becomes P is equal to the rate of vaporization multiplied by the latent heat. Now, latent heat is a constant, which means we can write rate of vaporization is directly proportional to P. Now, if we go back to the question, it's clearly mentioned that the value of P is increased. So if P is getting increased, of course, the rate of vaporization will also increase. Now, if we look at the options among C and D, rate of vaporization has to increase. That's why option D is the answer.